that is the weight of the floating body, is equal to weight of the liquid decrease. That is equal to L into A into density of the liquid rho into G. Now this can be replaced by directly. Intensity here is equal to I by first case, I1 is equal to 0 by R square. Second case, I0 by 2R whole square is equal to I0 by 4R square is equal to how much time? I1 by 4. Before loading, when it is excited, 8 beats in 2 seconds. Therefore, beat frequency is 4. Therefore, there are 4 beats. 8 by 2, 4. And therefore, the frequency of A can be 384 or 376. Now, welcome my friends. Today's video, we are going to discuss the questions from oscillations and wave. The very first question is there on the board. Go through the question. Two tuning forks A and B are sounded together giving 8 beats in 2 seconds. When fork A is loaded with the wax, the beat frequency reduced to 4 beats in 2 seconds. The original frequency of the tuning fork B is 380 than the original frequency of A. Suppose this is our A. Suppose this is our A and whose frequency is R, and this is our B, whose frequency is given as 380. Now, before loading, when it is excited, 8 beats in 2 seconds, therefore beat frequency is 4. Therefore, there are 4 beats, 8 by 2, 4. And therefore, the frequency of A can be 384 or 376. Now, then it is said that when fork A is loaded, when this is loaded, A is loaded, definitely the frequency must decrease because mass increases, frequency decreases. That means if it were 384, go below that. If it is 376, go below that when after loading. Whereas B remains the same, nothing happened to B, 380. In this situation, when they are excited, it is given that 4 beats in 2 seconds. The beat frequency becomes 2. And hence, the frequency of this body now 382 or 378. On loading, you know that its frequency decreases. If it were 376 earlier if the frequency decreases, definitely the value will go below 376. But here the possible value 378 and never go below that. Therefore, this option is not possible. Therefore, the value is equal to 384. The tuning fork frequency is equal to 384. So, okay. Next question. As shown in figure, a spring is kept in stretched position with some extension by holding mass 1 kilogram to 0.2 kilogram with a separation more than natural length and release. Now, 2 mass system oscillate. Then the time period, what is the frequency? Time period is given by 2 pi root of mu by k. Or frequency is given by 1 by 2 pi in the root of k by mu, where mu is the reduced mass two body system, and mu is given by m1 m2, 1 into 0.2 by 1 plus 0.2. m1 m2 by m1 plus m2, the reduced mass of the system, is equal to 0.2 by 1.2 equal to 1 by 6. Now substitute here directly. and get the frequency. Frequency n is equal to 1 by 2 pi in the root of k is given 150 by reducer mass is going to be 1 by 6. And get the value is going to be 30. This on calculation, the value is equal to 30. Next question. The speed of original longitudinal wave in a metallic bar is 400 meters per second. The density and Young's modulus of the material are increased by 0.5 and 1%. Then speed of the wave changes approximately. You know what is the relation between y speed of sound and through a medium and density? You know velocity v is equal to root of y by rho. And therefore, percentage error in v equal to half into error in y minus half into error in rho. Error in y it is given to you. Applying power rule. Error in y is given to you 0.5. Half into half minus. The other one is equal to 1%. Sorry, density and Young's modulus. I am wrong. Half into first one density. Density of bar increased by 1.1. 0.5 that is equal to half minus half into density 1%. Sorry, Young's. I'm wrong. Again, I am wrong. I'm sorry. This is wrong. It is equal to half into y. The y 1%. 1 minus half into half. It's equal to half minus 1 by 4. It's equal to 1 by 4% of 400. And therefore, then the speed of the wave. So change in velocity is equal to 1 by 4 of 400 by 100. That is the change in velocity. dV on calculation, this value is going to be 1. And therefore, the frequency become 401. Option is 4. Applying power rule. Okay. Next question. The displacement of a particle executing simple harmonic motion with a period t is expressed as starting from origin a sin omega t. Where is the amplitude? The maximum value of the potential energy. So this is the oscillator starting from mean position. Observation start from mean position. The question is maximum value of potential energy at the extremum. So the maximum potential energy maximum at the extremum. And what is the time taken by the oscillator to from here to here is t by 4. But in the answer is given that time t is equal to t by 2 beta is equal to t by 2 into 2. Therefore, comparing beta is equal to 2. It is easier question. So, okay. Next question. A point source is kept at the center of a spherically enclosed detector. The volume of the detector increased 8 times. So, earlier it was like this. Volume is V. Next case, the volume is equal to 8V, mean if radius of the earlier situation is R, distance from to the periphery is R, then distance from periphery to this one is equal to volume become 8 times, therefore radius become 2R or distance become 2R. Now intensity here is equal to I by first case, I1 is equal to I0 by R square. Second case, I0 by 2R whole squared is equal to I0 by 4R squared is equal to how much time? I1 by 4. and therefore the decreases by 4%. Intensity proportional, inversely proportional square of the distance. Decreases by 4 times. Okay. Next question. The fifth harmonic of a closed pipe is found in unison with the first harmonic of an open pipe. Ratio of the length of the closed pipe to that of the open pipe is 5 by x. Then the value of x. Now, this is a closed pipe. L closed. The fifth harmonic, y into V by 4LC. Nominal frequency of a closed pipe V by 4LC. And that is same as first harmonic of an open pipe. Suppose this is the open pipe, L open. Then the first harmonic is given by V by 2L open. They are same as per the problem. Now we will cancel out. This come 2. And the question is the length of the closed pipe. To LO by LC. If you calculate LO by LC is equal to 2 by 5. 2 by 5. Sorry. The length. The ratio of the length of the closed pipe to that of the open pipe. Ratio of the closed pipe. Oh, sorry. Wrong. I am wrong. This calculation is wrong. The ratio is ratio of the closed pipe LC by to that of the open pipe LO. LC by LO is equal to, we'll cancel out. This will be 2. LC by LO is equal to 5 by 2. LC by LO is equal to 5 by 2. This is 2. This cancel out. Here is 2, 5 by 2. Now the answer is compare with 5 by x. So you can say that x is equal to 2. So x is equal to 2. So that is the option. Again, a simple problem. Next question. A cylindrical block of mass m, area cross section A, is brought in a liquid of density rho and with the axis vertical. When depressed a little and released, the block start oscillating, the period of oscillation. Suppose this is the situation. This is the block immersed up to this H or L. This is height H or the block. This much is inside the liquid. Then standard formula. Standard formula is equal to time period T is equal to 2 pi root of equilibrium depth of immersion by G. Root of L by G. Equilibrium depth of immersion by G. Now we have to find L. Apply flotation, weight of the floating body. That's equal to area into H into density of the body into G equal to. What is the density of the body? Liquid density. So this is sigma, we can say. So this symbol I am changing. Sigma into G. That is the weight of the floating body. Is equal to weight of the liquid displaced. That is equal to L into A into density of the liquid rho into G. Now this can be replaced by directly M. M into G. G cancel out. From this L is equal to M by A rho. Now substitute this here. Time period T is equal to 2 pi root of M by A rho G. M by A rho G. And the option is equal to M by A rho G 4. Next question, 8.1. A simple pendulum of length 30 centimeter perform 20 oscillations in 10 seconds. The length of the string required to pendulum to perform 40 oscillations in the same time duration. Now in the first case, what is the time period? Time period of the pendulum is 30 centimeter length per 20 oscillations in 10 seconds. Our time for one oscillation will be 20 is equal to 1 by 2 seconds. First case T1. In second case, what they are asking? 40 oscillation in the same duration, 10 by 40. So 1 by 4 seconds. That means period is halved. Now what is the relation between time period and length? 2 pi root of L by G. So T proportional root L. So T1 by T2 is equal to root L1 by L2. T1 by T2 on calculation. T1 by T2 is equal to 2. 1 by 2 by 1 by 4 is equal to root L1. First case oscillation 30. So L2 is equal to what? This will grow up to squaring. 4 is equal to 30 by L2. Therefore, L2 is equal to 30 by 4. 0.75. The answer is equal to 0.75. So, again, next. In an organ pipe, Nu3 and Nu6 are third and sixth harmonic frequency, respectively. If V6 minus V3 is equal to 2200 Hz, then length of the pipe. Now, it is given that the frequency difference, third harmonic, 3 of fundamental, the other one is only sixth harmonic, 6 of fundamental difference. That is the difference between them is directly given to you as 2200 Hertz. 3F is equal to 200. F is equal to 2 by 3. This is the fundamental frequency. And what type of pipe? Open pipe. Then open pipe, open organ pipe. So this frequency is same as V by, for an open pipe is equal to 2L open. Therefore, 2200 by 3 is equal to velocity of sound is given to 330 by 2 into L open. From this, the length of the pipe can be calculated in millimeters. Find the value of L. L in calculation is 225 millimeters. This calculation give you in millimeter. The answer is us. We get the meter, convert that into millimeter, get the answer. Okay. Two loudspeakers, L1 and L2 are placed with a separation 100 meters, as shown in figure. Both the speakers are fed with the audio input signal, same frequency, the constant volume. A voice recorder initially at a point E, at a distance, both loudspeakers moved 25 meters along the line AB. Along the line AB, while monitoring the audio signal. The measured signal was found to undergo 10 cycles of minima and maxima during the movement. Then the frequency of the input signal is so much hertz. They are asked. Now it is similar to an interference experiment. Here we can see that I'm using some other color. Now, this is the equidistant point, path difference 0, where from here the path difference is equal to L2B. L2 path is given by L2B. So L2B is equal to 40 and this is 40 and this is equal to 30. Why? About root of 40 squared plus 30 squared. And that calculation yield you the value of 50. Whereas L1B on calculation, this distance, L1B is equal to root of 40 squared plus this, 40 square plus this distance, 25 minus by 20 square. That calculation yield the value 44.6. And therefore, what is the path difference from here and here? Path difference is equal to L2B minus L1B is equal to 50 minus 44.6. That calculation give you that is equal to 0.54. This is equal to 50, 44.6 is equal to 5.4. But it is given that the path difference from here and here is equal to 5.4. And this is the 10th maxima. 10 bands are included here, 10 bands. To have the 10th maxima here, the condition is equal to n lambda. Therefore, we can say 10 lambda is equal to the path difference. Therefore, lambda is equal to 5.4 by 10 equal to 0.54. Now you got the value of lambda. Now, what is the question? Question is the frequency. Once lambda is obtained, frequency f is equal to v by lambda. V is given 324 by lambda is equal to 0.5. This value on calculation, the value this on calculation is 50 hertz. So that is the answer, 600 hertz. So it's an interference experiment. So okay. Time ayo. Two question. ഇത് കഴിഞ്ഞിട്ട് മതിയില്ല, അത് കഴിഞ്ഞിട്ട് പോകാം. We continue. A simple pendulum bob with a mass m and a charge q, pendulum string has got negligible mass and uniform horizontal electric field is applied. Tension in the string changes. Final tension in the string when the pendulum attained equilibrium position. Earlier, the pendulum was like this. When it is charged one and horizontal electric field is applied, electric field is along this direction. And therefore, this reason there are two forces. This is the mg. And here the field force is equal to EQ. And this is the resultant of these two. So the tension is going to be root of resultant of these two mutual perpendicular. Mg whole squared plus EQ whole squared. Mg whole squared plus EQ whole squared. So okay. Option is equal to 4. Next. Kinetic energy of a simple harmonic oscillator. With the angular frequency, the kinetic energy of a simple harmonic oscillator oscillating with the angular frequency. So, angular frequency of kinetic energy, omega of kinetic energy given to you, 176. Now, the question is frequency of the oscillation. But if omega is the frequency of the oscillation, then displacement frequency, the kinetic energy frequency is equal to omega. That's okay. But omega is equal to 176. Therefore, omega is equal to 176 by 2, 88. So the option is equal to 2. Now, two strings A and B having linear densities mu A 2 into 10 raised to minus 4, and mu b 4 into 10 raised to minus 4 kilogram per meter. Length LA 2.5, LB 1.5, respectively are joined free and ABA tied to rigid support C and D, respectively, creating a tension 500 Newton in the wire. Two identical pulses sent from C and D and take time T1 and T2 respectively reach the joint, then T1 by T2. Now we can draw, this is the two wires, this is C and this is D, and here this is LA and this is LB. Now tension is the same because they are connected like series, and therefore tension is the same. You know, velocity V is equal to root of T by M. Tension is the same. Next, the time to travel, this much distance. Time is given by distance by velocity. Time. Next one that we have to, and therefore, what is that? The first case, what is velocity? The first case, T1 or TA is equal to distance is equal to LA. By velocity is given by root of T by MA, where MA is the linear density. Similarly, TB is equal to LB by velocity root of T is the same, but linear density is different, MP. And what is asked? T1 by T2. Therefore, TA by TB, T1 by T2 means TA by TB is equal to LA by LB in the root of MB by MA intensity. Now we are given LA and LB, 2.5 by 1.5, the root of linear density of B, 410 raised to minus 4 by 2 into 10 raised to minus 4. This one calculation is 1.18. So it's equal to 1.18. Now this finishes this video.